Hey guys, welcome to part 2 of our interview with Gabrielle Fundaro on gut health. If you haven't listened to part 1 yet, I'd highly recommend going back, listening to that one first, and then coming on to part 2. It'll just make a whole lot more sense. But here she goes. Enjoy part 2. Getting more into the fiber conversation, I've found personally a lot of clients that I work with, it's sort of that Goldilocks situation, right? You don't want too much, you don't want too little, but you want just the right amount. So can you tell us a little bit more about the various types of fiber that we can consume and then why they're important?
Yeah, so in terms of the number of grams of fiber that you'd want, general recommendations are 25 grams a day for females, 38 grams a day for males. Like I mentioned, kind of the tolerable upper limit is going to be about 70 grams. At that point, if you're eating 70 grams a day, you're probably going to be experiencing gas, bloating. You can actually experience some constipation because those gases will actually sort of build up and increase transit time. If you are experiencing symptoms of gas and bloating and things like that, even if you're a male, you probably would be okay if you transition back to 25 grams per day rather than aiming for, close to 40. So you're definitely right. There's a Goldilocks. We don't want to have, so little that we're deficient or so much that we're getting symptoms. In terms of the type of fiber, there are fibers that our bacteria can easily ferment, and then those that they are not going to easily ferment. And so that's actually of great benefit because we can still benefit from some of the effects of fiber in terms of creating bulk and sort of scratching against the intestinal cells and increasing the production of mucus, which will help with transit time without necessarily having the side effects of gas and bloating. So generally speaking, insoluble fiber, so things that we see like in skins of produce, it might look the same going out that it did going in. So insoluble fibers, or if you put them in water, they don't do anything. They don't soak up the water. They don't change shape. That you have an insoluble fiber. Those are usually less fermentable. And so one fiber supplement that can be beneficial for people that might want to have more fiber, maybe they're feeling constipated, but they don't want to deal with the bloating, is Citracell. That's methylcellulose. So it's not going to be readily fermented. Whereas more of our soluble fibers that we see in whole grains, like if you put oatmeal in water, it gets all soft. Those are going to be more readily fermented by bacteria. And so that's great because that's how we get those short-chain fatty acids, and it increases levels of our beneficial bacteria like bifidobacterium. But at the same time, you may be experiencing more gas from those things. So that's why if you are going to transition to the low Fodmap diet, you'll see that it's pretty low in most whole grain products, and there are a number of fruits and vegetables that it reduces as well. But there are still fruits and vegetables that you can eat. It's not that it is a really restrictive diet. It's just that we're trying to limit the types of fibers that may cause more gas and bloating. So that's kind of general rule of thumb. Like if it's not going to soak up water, you probably can eat more of it and not get as much bloating. Whereas if you put it in water and it gets really soft, that's a soluble fiber and that's more fermentable. And you do want to have a balance of both as much as you can, deal with that. Now, that being said, there are plenty of cruciferous vegetables that are high in insoluble fiber that will still cause gas and bloating, and a lot of people recognize them, like broccoli and cauliflower. So, those, if you do experience some gas and bloating and things like that, then you might want to just limit those.
Awesome. That's a great breakdown. Circling back around to birth, setting the groundwork for gut health and stuff like that, how do antibiotics impact the gut, the microbiome? And then, people when they're young, if they've been administered a lot of antibiotics, does that have a certain sort of lifespan that impacts the person? Is it, for their entire life? Or how should people work around antibiotic use or think about it in regards to their gut health?
So depending on the type of antibiotic, you can have effects that last days, weeks, months. If it's a long bout of antibiotics, maybe years. There aren't a lot of really like longitudinal studies that follow people for years after a bout of antibiotics, but there are some that have followed them for weeks or months, and we can see that there is some derangement that lasts after antibiotic use. That being said, we can look at the gut in terms of a species profile, like who's there, and then we can also look at it in terms of a functional profile. What are they doing? So while you may see a decrease in species diversity, you may not see a decrease in function, because a lot of these bacteria have overlapping functions. Like you have a bunch of bacteria that can ferment fibers. You have a bunch of bacteria that are aerobic, and so they're not just using glucose for energy. You have some that are metabolizing amino acids. And so even if you kind of knock out like one small part of your ecosystem, that doesn't mean that the whole thing is then going to crumble. Just like, we've had extinctions going on all the time in like the world and our ecosystem that we're familiar with, and it may affect like one small part, but overall, like our functionality is still kind of the same. So that's one thing to think about. And then also, when we're looking at characterizing what we call dysbiosis, that's sort of an umbrella term that just means like not a beneficial profile of gut bacteria, but we don't have a specific definition for what bacteria there are too many of or too few of. Because we used to say, too many Firmicutes and too few Bacteroidetes, and that's not really true anymore. So it gets a little bit murky in terms of like how are we actually classifying the effect of these antibiotics. Because like I said, you may lose some species diversity, but you won't necessarily lose overall functionality. That being said, I always stress that if you are given a round of antibiotics, take them according to your doctor's instructions fully, even if you're feeling better, because this is how we end up with antibiotic-resistant strains of bacteria. I mean, I'm certainly there's argument to be made about what's going on in agriculture and whatnot, but human abuse and misuse of antibiotics is a serious issue. So we need to make sure that we're taking the full course of antibiotics as instructed. Afterwards, or even during, if your doctor says it's okay, that's a time when we find that probiotics can help with the antibiotic-associated diarrhea. That's usually pretty common. I did have a couple people ask, like, can I, I've been on antibiotics for a long time, can I rebuild my gut bacteria? Probably not, because you have hundreds of species of bacteria in your gut. And we have like a few dozen that are available as probiotic supplements. And you have hundreds of trillions of actual bacteria in your gut. And you may only be getting like, 10 to 50 billion in a probiotic dose. And also, based on that recent study, maybe those probiotics aren't ending up where they're supposed to end up. Like ideally they pass through the stomach pretty much unchanged and then colonize in your colon. But we really don't have any studies that show like what are they actually doing as they go through. We can study fecal bacterial levels, but that's not actually telling us exactly what's going on in the gut, because there are some bacteria that hang out more in the lumen, like the inside of the intestine, and others that stick in the mucus layer. So we may actually see that there is in studies that are using fecal samples that they may be more biased to measure higher levels of bifidobacterium, because bifidobacterium hang out in the lumen. Those lactobacillus, those are going to be more proximal, and they can hang out closer to the mucus layer. So, that's something else to consider, that like these probiotics may be beneficial, but there's not a definitive statement that you can say about like this is what antibiotics will do and then probiotics will fix it. Not necessarily. We just can say they probably will help with diarrhea.
Okay, yeah, that's fair. Now, do we see a difference between using antibiotics in the 0 to 2 to 3 year old range versus using them as an adult, being that the microbiome isn't fully developed yet, or it's not an adult microbiome, as you put it. Do we see a difference there in the impact of using antibiotics?
Now that I'm not entirely certain about. I would say that a lot of people have theorized that early antibiotic use might be a factor in the development of later development of things like ADHD or, other mental health issues. Because if, you're starting a child very early on with sort of a delayed colonization, or they've started to be colonized and then you sort of, wipe some of that out, then instead of having colonization very similar to the mother if it was a vaginal birth, then maybe they're being colonized with more environmental bacteria. But that can also be a good thing, because there are other theories that if you're living in a very sterile environment and you're not exposed to potential pathogens or allergens, that you are more likely to develop allergies later in life. So I can't give like a definitive answer to that one, but I would say, it probably does have an effect. We don't know what yet. And there are a lot of sort of far-reaching, I think, opinions about some of what we're exposed to in the environment and like what effect that might have. Like, for example, I just read an article on glyphosate, which is, the ingredient in Roundup. Everyone's hating on it. And I am very much a proponent of the dose makes the poison. And so, in this study, they fed these rats the ADI of glyphosate, which is, I believe, 1.75 mg per kilogram. It would be incredibly difficult to actually ingest that as a real person. And they saw derangements in the microbiome of the pups, of females who were fed this. But to then from there extrapolate and say, oh, well, clearly this is going to have an effect on the microbiome, I think is really far-reaching. And that's some of what, because it publishes well. I mean, it's really sexy to make these, to come up with these theories and whatnot. But you have to look at the dose, and you have to look at, the relevance of that model to the human microbiome.
Right. Yeah, I'll probably butcher this, but I remember hearing something about a study based on the closer that the mom was while she was pregnant to something like a farm, and the more access she had to sort of just bacteria or like varying bacterial environments in general, the less allergies and sensitivities that the kids had down the road anyways, which is really interesting, that exposure could potentially lead to tolerance.
Yeah, absolutely. I mean, because that's really, your first exposure is, your mom's microbiome. And it's not even just the vaginal, but, breastfeeding, we have a skin biome as well. So anything that you come into contact with via birth, breastfeeding, that is going to affect your biome. If you have pets, that's going to do it as well. So, some of these recommendations now are changing even about exposure to like possible allergens like peanuts and things like that early in life. Yeah.
So what's the antimicrobial like pumping stuff that people use all the time? What is that shit?
The triclosan?
Yeah, it's in gyms, it's everywhere. It's on your way out the bathroom, whatever. Like, I don't know. You don't have to go crazy with that stuff.
Right. And the funny thing is, actually, you can just like rinse your hands with cold water, and that removes a lot of the bacteria. You don't even need to use antibacterial soap. Just like the friction and everything, like that gets rid of a lot of bacteria. And so, and you're, not to say we shouldn't be washing our hands. You absolutely should be washing your hands. But the overuse of some of these things, it's that might be contributing to some of the issues that we see with resistant bacterial strains and whatnot. And it's like, well, you are sort of like a meat donut. Like you, the hole that goes from one end to the other is actually technically external, and you have a lot of immune receptors there. That's like your first line of defense. So, if you come into contact with pathogens all the time, and really your immune system deals with them very well. But, that being said, I still wash my hands when I come home from the gym and stuff like that. Like, I'm not saying not to wash your hands, but, that's another theory that maybe because we're using these things so often that we're in some ways affecting, our gut microbiome, our skin biome, and things like that.
Yeah, that's a cool concept that you touched on as far as, the gut being almost outside the body in a way, because when food goes into your mouth, it goes down to your stomach and then out the back end. It shouldn't technically be getting into places that it shouldn't technically be getting into. And then I guess that's where leaky gut plays in a little bit and causes some issues. So that's a super important point, and just like a visual for people to kind of take on, right?
Yeah, exactly. Yeah, that's what I used to tell my students. We are a meat donut. And so, like, if you weigh 100 pounds and eat a pound of nachos, you are not then 1% nacho. Those nachos are external to your body.
Right. So, this is probably, potentially a poison is in the dose sort of deal too, as well as the glyphosate that you touched on. But how are artificial sweeteners potentially impacting our gut? Do we need to worry about them? Is the dose just ridiculously high in order to have a negative effect? How should we think about that?
I actually do touch on this in the RP Diet Book 2.0.
Cool.
So I don't want to give away too many spoilers because I want people to read it. But I will say, yeah, you're right. It's just this that the dose makes the poison. And if you are consistently ingesting the ADI of these sweeteners, which is in grams per kilogram of body weight, or really high mgs per kilogram of body weight, just to the point where it would be very difficult to actually ingest that much. I mean, we're talking about like multiple cans per kilogram of body weight per day. Then yes, you could see a derangement in the microbiome. And there have been a small handful of human studies where they've done this for, a couple months at a time. And it's also person dependent. So in some individuals, there's no derangement. In some individuals, there is a derangement. And of those individuals that experience a derangement, some of them will recover once the artificial sweeteners are stopped, and others won't. But there are, so there are like those are like the non-nutritive, aspartame, saccharin, sucralose. Those are the non-nutritive types. If you talk about sugar alcohols like maltitol, xylitol, erythritol, those can be metabolized by the bacteria, and those can actually really contribute to bloating and gas. They can have a laxative effect. So those are actually more likely to have an effect on the microbiome, even though they have sort of this health halo effect because, they're in a lot of health foods and protein bars and things like that. But those are a common contributor to a lot of gastrointestinal issues. So, that if you're worried about the effect on the microbiome, and it's probably because they're, fermentable, and it might not be a bad effect, but it's going to have an effect because we can see that, there's an increase in gas production and a laxative effect. And if you are having, a chronic diarrhea and you're seeing a regular laxative effect, that'll certainly affect the microbiome because now you're reducing their time with the nutrients in the gut.
Yeah, that's a great point. And I know for me personally, aspartame, sucralose, all that stuff, I tolerate just fine. But the sugar alcohols, like not cool. Not cool.
Oh yeah. No, I really love the taste of a lot of these like new high protein ice creams, but the sugar alcohols, even in the non-dairy versions, I cannot handle. I mean, it's just not worth the discomfort for me to even eat a serving.
Cost
I'm
benefit,
like, you want me to eat the pint? Yeah, no, that's not going to happen.
Totally.
But I use Splenda. That's sucralose, and I have no issues with that. And I've had no issues with using like aspartame. I mean, I'm not funded by any of these or anything like that. But
wait, you don't have an aspartame sponsorship?
No, Monsanto's not paying me anything.
Yeah.
But yeah, I tolerate those just fine.
Yeah, I'm the same. Now moving on to sleep. I don't know if you're going to touch on this in the book. Do we know how sleep impacts the gut, long-term, short-term? What's the relationship going on there?
I haven't looked too much at sleep specifically, but I did see an interesting study that looked at a 4-day military exercise, and they're not going to be getting good sleep. And they supplemented them it was either a control or an extra protein or extra carbohydrate supplement on top of their normal food rations. And the supplementation, like the extra calories, did not help them. They actually did see increased intestinal permeability. So while that's not, I can't say definitively anything about like sleep just because I haven't looked at it yet, but stress in general, heat stress, strenuous exercise, and it might be increased sympathetic nervous system tone also that contributes. That seems to increase intestinal permeability. So it's just, and it's prudent anyway. Like if you are exercising really hard and you're having some sleep disturbances, maybe you're in like an overreaching phase, you need to rest and recover. You need to give your nervous system time to have that increased parasympathetic nervous system tone, recover, and so sleep definitely. I would hypothesize that sleep would certainly have an effect on the microbiome.
Okay, cool. From a practicality sense, if somebody comes to you with gut issues, and you kind of, spoiler alert, touched on this with the Fodmap stuff, but where do you typically have them start? So do you start with an elimination approach, see how they respond to that, include some foods back in one at a time? How do you like to set that stuff up?
Mm-hmm. I try to be pragmatic about my approach and also know that, this person has been experiencing this for however long, and they are the expert on themselves and how they feel. So my priority is always going to be their experience. Since I don't have my RD yet, but that's the plan in the next few months. I'm working towards that. I don't give medical nutrition therapy. So what I can do is give recommendations based on the best evidence that we have for people who have IBS-like symptoms. And that is a reduction in dietary fiber and kind of specifically this reduced Fodmap diet. So Fodmaps are different types of fibers, different types of saccharides or carbohydrates that are fermentable by the gut bacteria, and that fermentation process leads to the production of gases, and that can contribute to bloating and constipation. So that's really my first approach is, I find out kind of what they've been doing, what supplements they're taking. And in a lot of cases, they're taking probiotic supplements that may be making the issue worse because probiotics do have side effects that include gas and bloating and, sometimes a laxative effect or constipation. I mean, so it's not that they're completely innocuous, like they do come with side effects. And they may be taking fiber supplements, and it may be a fermentable fiber that's causing even more gas. And then they may be taking a handful of things that don't have any evidence basis. And, it's just somebody making a buck. So usually I recommend, because we don't even know if one of those things is helping, we can't even determine what, because we have so many variables going on. So probably it's best to discontinue those for now if they feel comfortable with it, and then try the low FODMAP diet if they're comfortable with that. Or, if there's just one thing, like maybe they want to try and remove gluten-containing foods. Okay, that is what their experience is important, and I give my guidance, and here's what we know based on the evidence. And then from there, trying to add foods back in. So rather than throwing a bunch of stuff at them first, it's better to simplify and find out what foods are tolerated well, and identify are there some foods that they're eating that are really probably obvious. Like a lot of people have lactose intolerance. Even if they were lactose tolerant when they were younger, most people develop it in adulthood. So lactose is a big one. Any of those sugar alcohols, because a lot of people coming to me have, they're fitness minded and they're eating products that contain, especially erythritol is really common. So those are big ones. And then like in their protein powders, if they pick whey protein concentrate versus whey protein isolate, whey protein concentrate contains lactose, whereas whey protein isolate doesn't. So those things can make a big difference. If they're taking the concentrate, I say, okay, well, maybe you want to try an isolate, or even, you can not opt for a dairy protein, and pea protein looks to be thus far in the literature equivalent to whey protein in terms of metabolic effects. So that's my approach, is just to kind of simplify and narrow down what's tolerated well, and then start to add foods back in. Because I don't ever want a person to feel like they're very restricted. That Fodmap diet is not meant to be a lifestyle forever. It's meant to be just a short phase, and then starting to integrate foods in after a couple weeks.
Love it. Let's chat about, the difference between fats and carbohydrates in the diet, and how that affects the microbiome or just diversity, all that sort of stuff.
Yes. So there have been some studies that have looked actually specifically at a ketogenic diet in humans it was, somewhere between 4 and 6 weeks. I think it wasn't a super long time, but it was enough to see that ketogenic diet actually reduced bacterial diversity. It could be due to reduction in dietary fiber and obviously carbohydrates, because a ketogenic diet is pretty much nil when it comes to carbohydrates. So based on that and epidemiologic studies and mouse feeding studies, I feel confident saying that a diet that is less than 40% calories from fat, that contains sufficient fiber and complex carbohydrates and plenty of plant material, is going to be more beneficial in supporting bacterial diversity and specific strains of specific species of beneficial bacteria, like those bifidobacterium specifically. That's like a really big one, because they are so good at making these short chain fatty acids for the enterocytes. And they also, it's not even just gut health, but in terms of appetite regulation, that's been associated with a protein called GLP-2, which may control appetite and also serve barrier functions as well. So it's sort of like a twofold benefit to increasing your fiber intake, is that it's good for your gut, and it also may help regulate your appetite. Another one that people have really jumped on the bandwagon with is intermittent fasting and its effects on the gut microbiome. Well, I just want to burst some bubbles and say that there has been one study on intermittent fasting and the gut microbiome, and it was done on fruit flies.
Oh, interesting.
So, yeah. So be careful with those extrapolations. But I think there was another one on like alternate day fasting in mice. But yeah, we have to be very careful about what kind of statements we're making that sound really conclusive and really exciting. I like to make mine based on like a lot of information that we have thus far. So that's what we know about, carbohydrate versus high carbohydrate versus high fat. I know there was that study that just came out that showed, high carbohydrate or low carbohydrate, either extreme is, greater risk of all-cause mortality, and eat about 50 to 65% of your calories from carbohydrates. That seems to be the safe range. Well, that's been the acceptable macronutrient distribution range for a really long time. That's not groundbreaking, and to me it seems very pragmatic. The dietary guidelines for Americans say, make half of your grains whole, and so that's the take home for that. So then, in terms of what kind of fats we want to ingest, we can have saturated fats, which are solid at room temperature, and then unsaturated fats. Usually they're going to be liquid at room temperature, but most foods are going to be a mix of saturated and unsaturated fats. But when we look at saturated fats, we usually associate those with animal products. And so we have to take that into consideration as well when we're making these recommendations and saying, a diet that's higher in saturated fats is associated with lower microbial diversity and lower levels of beneficial bacteria. That may also be due to what else is going on in the diet, not necessarily that it's just due to the saturated fat. But if we're eating a diet that's really high in saturated fat, are we also lacking fiber and things like that? Is that sort of mimicking the westernized diet? When we look at unsaturated fats, we don't see that they really do all that much to the microbiome. Omega-3s might have a modest beneficial effect, but there just hasn't been that much research done in that area. But in terms of general health effects, we know it's better to eat more unsaturated fats. A lot of, then the coconut oil study came out, or that statement, coconut oil is bad as poison. No, when you look at the actual research, it does not have as great of an effect on LDL cholesterol as butter, but it's not that it doesn't have an effect, but it's not poison either. So, you can include that. It just should not be a dietary staple.
Just maybe don't drink gallons of it in your coffee.
Yes, don't put it in your coffee. Oh my gosh. Oh my gosh. Yeah. But we see kind of the same thing with plant proteins versus animal proteins. A diet that's really high in animal proteins has been associated with, in limited evidence, that it's associated with the production of some harmful metabolites. And also an increase in mucin degraders. So those are bacteria that could break down the mucus layer of your gut, and that could be very deleterious. So part of the kind of the other part of leaky gut, it's not just that you have a reduction in the tight junction proteins, but also that you have a thinner mucus layer. And that's also what we've seen with these high-fat diets in rodents, is that the mucus layer protecting the gut is thinner. Whereas with plant proteins, we see an increase in our bifidobacterium and lactobacillus, and sort of a concomitant decrease in some of those mucin degraders. And we often see that when one type of bacteria goes up, another one will go down, because they are sort of competing for real estate, and we are fostering an environment in which some will thrive and others will not, by modifying their nutrient availability and even pH in the gut. So I've been looking, and I don't know all that much about this yet, but looking at sort of the role of bile acids, because that's something that we use to digest fats, and obviously it's going to acutely change the pH of the gut. And we have pH changes going on all the time as food is entering the duodenum, and then we're secreting bicarbonate and things to neutralize that. So those are things that we could take into consideration as well. And I'm not promoting the whole alkaline versus acidic diet thing. That's not. Oh my gosh, that's been.
That was debunked a while ago. Yeah.
Yes, exactly. Yeah. But just being cognizant of the whatever we're putting in there, that is going to acutely change the pH, and so that can be part of the mechanism behind why our diet could be modifying the gut microbiome, in addition to what nutrients we're providing.
That's an awesome breakdown, and the pH alkaline diet sort of situation is a whole nother can of worms, because it's not that it's not helpful or beneficial for people to follow a quote unquote alkaline diet. It's just that you can't influence your blood pH by ingesting food. Alkaline water is not doing, and so it's just holy shit. Yeah. Oh,
exactly. Yeah. I'm why can't people just eat fruits and vegetables just for the sake of eating fruits and vegetables? It's so not fancy. And I'm and I thought I put in my bio for Renaissance Periodization, that I support eating a plant-based diet. And then I thought, oh gosh, people are going to think that I'm vegan, and I don't want people to think that I have any sort of dogma aside from you should be eating a lot of plants in addition to everything else.
A plant-centric diet. Yeah, it's like...
Oh,
yeah.
that's what I need to be saying. Because I was like plentiful? Plant-based omnivorous? I don't know I'm going to contact them and say, hey, can you change this to plant-centric, please?
No matter exactly what, you're going to piss somebody off, so it doesn't even matter, right? It's like...
Exactly.
Well, Gabrielle, that's an awesome place to wrap up. If folks want to learn more about you, your work, where can they find you? Let us know.
So I am on the RP website. So if you go to renaissanceperiodization.com and you go to our team, they can find me there. I also have a blog that I don't update often enough, but that's
you and me both.
Huh?
I said you and me both.
Yeah. Oh man. But that's at vitaminphdnutrition.com. So I have, I probably blog every couple months or so, but I put updates there every time I do a podcast or I give a seminar. I post that up there, and it's probably easiest to find me on Facebook or Instagram. Those are both Vitamin PhD. And I'm much more active on Instagram and Facebook. So, if RP ever has a sale and I put up, I'm going to be at a seminar in Southern California, October 20th through the 21st, Performance Summit with a few other RP folks out there. And I've got another podcast coming up next week. I don't know when it's going to be live, but yeah, anytime that I do something, I try to update that and post science and pictures of my dogs and salads.
That's awesome. I will link to all that stuff in the show notes, and thank you so much for taking the time. That was, I really enjoyed nerding out. That was great.
Oh, that was super fun. Thanks for all the good questions.
So that wraps up part 2 of our 2-episode series on gut health. I hope you guys learned a ton and really enjoyed that deep dive. Now, if you are getting value from the podcast, it would be amazing if you could write a review, share it on social media, even sending it to a friend. If you listen to it, throw it up on Instagram, whatever. However you can help the podcast grow and let us reach more people and essentially help more people with their health, the better. But thanks again for listening, guys, and I will catch you guys on the next episode. Bye.